All right, so let's move on to lesson 3.2, where we are going to actually analyze our linear functions. So now we're going to take a lot of that information that we learned in Unit 2 and apply it here, and we're going to learn a few new things also. So pictured below is the graph of a linear function. We're going to define the terms that are in the boxes below and then identify the given characteristics about f of x, which is graphed. So remember, we've talked about there are going to be three different ways that you can represent a function: numerically, which is like a table of x and y values; graphically, so which is what we have here, a graph; and then analytical is when you actually have the equation that gives you this graph or that table of values. All right, so left-in behavior. Left-in behavior is a new concept. Left-in behavior is a statement that describes the values of y. So what y is doing. What are the values of y as the x values get smaller? So as we go off to the left, so as the x values, we say they approach negative infinity, right? So on this graph, as our x values go to the left, as we move left on the graph, but we're on the graph, what are our y values doing? So as my x values go way to the left, my y values just keep getting larger and larger and larger and larger. They head towards positive infinity. So we say as x approaches negative infinity, and we use that arrow for approach, f of x approaches positive infinity. And this is using capital F, so I'm going to do the same thing. Change my... Now, a couple of things to remember. This arrow means approaches. And remember that f of x just means the y value. Okay. All right, right-in behavior is very similar. It is a statement that describes the values of y as x gets really large. So now our x values are approaching positive infinity, okay? So let's look on our graph here as we head out to the right, as our x values go way out here forever and ever, and I'm on the graph, my y values just head towards negative infinity. It's going to keep going down and down and down forever and ever. So the way we write that characteristic on our particular f of x in this particular function, as x heads to really large numbers, f of x is heading towards really small numbers, getting lower and lower and lower. Okay, let's remember slope. Slope is vertical change divided by horizontal change okay? So we say change in y over change in x. That delta symbol, this little triangle, is delta. It means change, okay? Equation of the function. If we had this equation here, it would be a function, we're calling it f of x. It's a linear function, so we would say ax plus b. A is going to be our slope, and b is going to be our y-intercept. So this is the definition. In this particular function, if we look at our function, what is our slope? Well, it's a decreasing line, so our slope's going to be negative. I'm going to pick 2 points. Here's a point that I can tell where it is, and here's a point. And to figure out my slope, I'm going to do my vertical change. So I'm going down 2, and I'm going right 3. So I went a negative change in y and a positive change in x. Down 2, right 3. Down 2, so forth and so on. If I go the other direction, I can go up 2, but then I go a negative x. So up 2, left 3, up 2, left 3. Which means my slope, my vertical change is 2, and my horizontal change is 3, and one of them has to be negative. And then where does this cross the y-axis? B is going to be 2. Crosses the y-axis at 2. So my equation is going to be f of x equals negative 2/3 x plus 2. Now, the zero of a function, this is going to be something that we're going to talk about a lot. The zero of a function is going to be where, okay, the value of x, where f of x equals 0, right? So on a graph, that's going to be on the x-axis, or what we call the x-intercept. Okay, so graphically, if we want to know where the function equals 0, where f of x equals 0, that means the y value is 0. So we're going to go look at our graph. Where does it cross the x-axis? It crosses the x-axis at x equals 3, all right? Algebraically, so we would say crosses the x-axis at x equals 3. We can tell that by looking at the graph. So this is how we would do it graphically. If we want to do it analytically, using the equation, we take our equation for f of x and we say, all right, f of x, negative 2/3x plus 2 has to equal 0, okay? Set the function equal to 0. So to solve that, I'm going to subtract 2 from both sides. And then I'm going to multiply by negative 3/2. Negative 3/2. Those cancel, and I get x equals positive 3. So clearly, it matches up at the same place.